AI Revolutionizing Agriculture. It is estimated that more than 1 billion people around the world work in agriculture, with a contribution of about $2.4 trillion to the world economy. So it is a significant foundation to the world economy. However, the agriculture industry across precision farming, livestock, aquaculture, and greenhouse farming is facing serious challenges from a growing world population with increased demand from food and related agricultural products. Assuming current growth rates, food production needs to increase by 70% to feed 9.1 billion people by 2050, where 70% will be urban and have higher income levels. The United Nations estimates 9.7 billion people. This can be addressed by advanced farming techniques supported by smart technology-driven farming solutions to increase the agriculture crop production as well as the demand for protein-rich aqua food. As a result, the smart agriculture market has also seen significant growth from $13.8 billion in 2020 to $22 billion by 2025 at a compound aggregate growth rate of almost 10%. Goldman Sachs GIR has a similar estimate of approximately $20 billion by 2025 for the smart crop agriculture market and assumes a 25% value creation by AI and IoT for the crop agriculture market of $1.2 trillion by 2050. They project that within just protein agriculture, another $20 billion can be generated through the use of AI applications for precision breeding mechanisms as well as disease prevention and treatment. Apart from the pressure on the food supply system, modern farming techniques and growing income levels, this growth can also be attributed to increasingly instrumented smart agriculture and aquaculture farms, as well as advanced livestock monitoring and disease detection to help increase farm yield by applying smart technologies such as AI and IoT, along with global positioning systems, drones, sensors, radio frequency identification, and light-emitting diode grow lights. With this type of instrumentation, huge sets of soil, satellite, and aerial imagery, weather, temperature, precipitation, wind speed, solar radiation, video, and audio data can be assembled for monitoring, data mining, and predictive analytics purposes. It is also clear that yield monitoring applications using precision farming technologies can provide farmers with the information, predictions, and insights about soil properties, fertilizers, and weather conditions. As an example, GSGIS estimates that corn yields in the USA can be improved by 70% by 2050 by using AI-driven technologies such as precision fertilizer and compaction reduction. They also project that from a global crop agriculture value perspective, potential increases in global crop yields from smart technology-based solutions could generate more than $800 billion in increased value by 2050 through precision irrigation, precision planting, precision fertilizer, precision spraying, compaction reduction, and moisture sensing. Machine learning solutions can also help to decrease irrigation and fertilizer costs, reduce labor costs, improve the quality of agricultural products, detect potential crop or livestock diseases, increase the productivity of human workers as well as land and equipment use, and enhance decision-making with respect to irrigation, fertilization, planting times, and livestock care. Some specific use cases for deploying AI solutions in the agricultural sector includes crop harvesting and soil monitoring, predictive analytics of environmental impact on crop yields, determining time sowing, weed control, diagnosing soil defects, automated irrigation systems, crop health monitoring, saving plants, help IoT achieve its maximum potential in precision agriculture, image recognition and insights, intelligent virtual assistants and advisors for farmers, agricultural robots, drones, and driverless or smart tractors. These smart autonomous tractors can, for example, be trained or programmed to independently make decisions on speed of operation, detecting their plowing position, and avoid obstacles in the farm fields while performing various tasks. Deforestation and degradation of land, in particular soil quality, remains a key global issue for this century due to its negative impact on the food security, agriculture, and economic productivity, quality of life, and the environment. The cost for erosion from agriculture in the US alone is already about $44 billion per annum. P.ai's PlantX solution makes use of machine learning driven image recognition to diagnose infected crops and offers treatments for any disease, pest, or nutrient deficiency issues. Another AI-driven soil defect analysis solution to help optimize healthy crop production is the one from Trace Genomics that utilizes soil science, genomics, and machine learning to measure the bacteria and fungi in soil that cause disease and cycle nutrients and combine those measurements with soil chemical characteristics. Agricultural robots can help to increase production yields at higher volume and a faster pace compared to human workers by, for example, using drones, robotic arms, and autonomous tractors to automate some common repetitive tasks such as mowing, harvesting, picking, sorting, packing, pruning, thinning, spraying, seeding, controlling weed, planting seeds, and milking and washing livestock. Other benefits of these smart technology solutions are lowering production costs, decreasing the need for manual labor, and producing higher quality of fresh produce. According to estimations by the Weed Science Society of America, the impact of uncontrolled weeds on soybean and corn crops in the USA and Canada has led to the annual losses to farmers of approximately $43 billion. EcoRobotics' solar-powered weeding robotic platform called AVA provides high-precision targeted application of herbicide for ecological and economical weeding of row crops, intercropping cultures, and meadows, whereas their fully autonomous solar-powered robot platform ARA is used for scouting and phenotyping applications and can move according to a predefined real-time kinematic global positioning system trajectory in autonomous fashion whilst minimizing soil compaction. Blue River Technology, which is now part of John Deere, has a robot called See and Spray, which uses AI-driven machine vision to provide precision spraying of weeds on cotton plants, which also helps prevent herbicide resistance. NIO Technologies also has a range of robots that can weed, hoe, and assist during harvesting of vegetable crops and vineyards. Energit provides a robot that can pick citrus fruit every 2 to 3 seconds at comparable cost to human labor, whereas Harvard's CROO robotics robot helps strawberry farmers pick and pack their crops at a rate of 8 acres a day and matching the equivalent of 30 human workers. Drones are also starting to play a significant role in monitoring large crop areas. Robotics in South Africa is, for example, using drone imagery and AI to get insights and identify problematic trees, as well as assist with the management of orchards, pests, diseases, and provide yield estimations. VineView is another leading provider that leverages aerial technology and AI to monitor crop health with their use of aerial-based sensors, machine learning, and other advanced algorithms to help grape growers make responsive and informed vineyard management decisions. VineView Solutions involves achieving vine balance, optimizing harvest scheduling, eradicating grapevine disease in vineyards, and improving irrigation and conservation of water. Agribotics' drone-enabled farm lens data analytics platform, which is now part of AgEagle's service offerings, provide the agricultural supply chain with AI-driven advanced analytic capabilities to identify areas where they can build soil health and reduce water or chemical usage. Vision Robotics has a range of agricultural mechanization solutions that includes a lettuce thinner, weeder, and an autonomous intelligent grapevine pruner and crop load estimation for apples on a tree, strawberries on a plant, and branches on vines. One of the US-based companies that specializes in providing machine learning-driven weather intelligence is Aware, which provides in-time weather, maps for economic resilience, weather insights and predictions, crop sustainability analysis, pest and disease modeling, fertilizer timing recommendations, and other related digital agriculture solutions. Within livestock and dairy farming, losses due to animal disease or distress is also significant. GSGIR has, for example, estimated that the annual loss within the global dairy farming amounts to more than $11 billion, which is predominantly because of preventable lameness among dairy cows that leads to decreased fertility, treatment costs, and milk loss. Machine learning-based applications can help to enhance breeding and health conditions by absolute cost reduction and recovering lost potential revenue. This is also the case in poultry production, where, for example, $2 billion in losses can be prevented by early machine learning-based detection of 2 treatable diseases in chickens via auditory data analytics. Another application area for AI in its use for highly instrumented vertical farming, where crops are grown in a controlled environment, typically without natural light or soil, but using water, light-emitting diode, LED, lights, and nutrients. It typically involves perception technology, such as cameras and various sensors, as well as automated and even autonomous mechatronics, where AI is used to process the data to improve efficiency, reducing costs, and optimizing nutritional value to the crops. There are predominantly 3 alternative growing systems in vertical farming. Hydroponics is where the plant's roots are submerged in a continuous flow of nutrient-based water. Aquaponics is the same, but instead of manually providing nutrients, this is done via a fish tank that is connected to the plants, with the fish wastes being the nutrient source. And aeroponics is where the plant's roots hang in the air and a sprinkler system sprays them with nutrient-based water rather than it being submerged. The vertical farming market is projected to grow to $7.3 billion by 2025, with hydroponics growth mechanism accounting for the largest size of this market over this period, with a number of companies providing smart technology-based vertical farming solutions such as AeroFarms and Plenty in the USA, Signify, the Netherlands, Osram, Germany, Valoya, Finland, and Heliospectra, Sweden in Europe, and Everlight Electronics Company Limited, Taiwan, Sky Greens, Singapore, and Spread Company Limited, Japan in Asia. According to Markets and Markets research, some of the key driving forces is the need of sustainable farming to meet the demands of an increasing world population, the growing demand for a substitute to traditional agriculture, and more partnerships being formed between technology providers and vertical farming companies. The Food and Agriculture Organization, FAO, of the United Nations, in their How to Feed the World in 2050 paper, has given a well-articulated outlook for food security towards 2050, incorporating the changing socio-economic environment, the natural resource base with respect to land, water, and genetic diversity to meet the demand, and the potential for food security. They specifically state the prerequisites for global security as enhancing investment in sustainable agricultural production capacity and rural development, promoting technology change and productivity growth, where smart technologies such as AI can play a massive role, and trade markets and support to farmers. The risks and challenges are that there can be hunger whilst adequate overall supplies without effective social safety nets for the poor, and a global trading system that is fair and competitive, as well as climate change and increased biofuel production's impact on long-term food security. Although the planet does have considerable land reserves with rain-fed crop potential, especially in Latin America and sub-Saharan Africa and some industrial countries, the lack of access and infrastructure, as well as the loss of important ecological functions due to uncultivated lands, will likely restrict the arable land to be only expanded by another 70 million hectares, about 5%, by 2050. According to the FAO, the suite of technology options should be as comprehensive as possible, which might include new plant varieties and animal breeds that are able to better adapt to changing conditions, smart technology-driven farming systems that lead to a reduction of losses and waste, saving of water, improved labor productivity, and optimized management of natural resources. They also stress the need for countries with limited import capacity to improve their production system productivity and resilience for raising rural incomes and to help local agriculture to compete better with low-price food imports. So let us take sub-Saharan Africa as an example. Given that the agriculture sector accounts for 32% of its GDP and employs more than 65% of Africa's labor force, it is clear that this sector is key to its growth. Given the significant projected population growth, rapid urbanization, along with rising income levels, alterations in national diets, and more open intra-regional trade policies, the World Bank estimated that African food markets will more than triple to be worth $1 trillion by 2030 and the demand for food to at least double by 2050. Innovative smart technology solutions are necessary to address the many obstacles and constraints sub-Saharan Africa face today, which includes reduction in soil fertility, emerging pest resistance, increased dependence on inorganic fertilizers, degradation of land, reduced water tables, increased vulnerability to climate change, inefficient resource usage, weak supply chain, and low productivity. The AI-driven smart technology solutions outlined in this section and apply to also empower smallholder farmers can contribute significantly to help local agriculture to improve productivity and efficiency across the agriculture value chain. GSGIS estimates that AI-driven solutions could help generate more than $1 trillion in value based on the potential savings in crop input, dairy and livestock, irrigation, fertilizer, sortation, and labor, as well as disease prevention and treatment, and increases in yields across the agriculture value chain. Given that AI solutions will help to limit waste and improve preventative methods, they also expect that the global market for fertilizer, veterinary pharmaceuticals, pesticides, fungicides, and herbicides will be significantly disrupted over the next 5 to 10 years.